Okay, so we're reviewing exponentials, and this is an exponential because in the x is in the exponent. So you can just think this through and go, oh, 2 to the third is 8, so the answer is 3. But are you aware, what you really can do for even ones you can't do in your head, is you could change this 8 to a 2 to the third, and then you made the bases the same. So then the answer is already up there. Do you remember that deal? You make the bases be the same, and then the answer will be up in the exponents. All right, so let's see if that's coming back. 4 to the negative 2 equals 2 to the 2x. Are the bases the same right now? No. Can you make them the same? Yes. All right, take a second, make those bases be the same. And no, you can't just say, I'm changing the 4 to a 2. 2 and a 4 aren't the same thing. You can't just change the 4 to a 2. But you can change the 4 to a 2 to a power. And don't forget to bring down the negative 2. Did you pick up what I was laying down there? Did you make this into a 2 squared? All right, and that brings up an important point. You need to remember how to deal with powers to powers. So there's like 4 different ways that that can happen, but one thing at a time. Would you agree that this comes out to negative 4? Okay, so then it's 2 to the negative 4th equals 2 to the 2x. So therefore, negative 4 equals 2x. And you can divide by 2, and you get negative 2. Raise your hand if you had negative 2. Okay, good. Now, that's making the bases the same. Let's try a little harder level of that one. And then I'm going to give you 3 more problems that are from this unit and could be on the final. And let's see if you can answer the one we just practiced and these 3 more. Okay? I'm not going to make them super hard, but you'll see. You've probably forgotten a fair amount of this stuff. All right, so to make one just like that where we want to make the bases the same, I'm just going to make it a little nastier because you'll probably have to change both sides. Because you can't just change the 4 to an 8. You can't just change the 8 to a 4. So make them both have different bases. And then on this one, I'd like you to find 3 points on the graph of four times 1/2 to the x. You had to graph these things. Then there was problems where you just had to know how to deal with like the negative exponents and like where do they move and simplify the green one. And then we'll make a blue one here. There's your 4 problems. These are all very reasonable things you could see on the final. And since it is a review day, you're supposed to know them. Maybe the kid next to you will be able to help you a little bit. But try these 4. Check with the kid next to you. Then I'll drop some instruction on you in case you forgot. So on this first one, hopefully you realize that the good base to change them both into is 2. So instead of this 4, we're going to put a 2. But you can't just say 2. You got to say 2 squared. And then this 2x can come down. And over here, this 8, that can be made into a 2 to the third. And then bring down the x. And now that the bases are the same, this has to equal that. So 6x equals 3x. Now, you might feel like, wait a minute. Oh, sorry, 4x. 4x equals 3x. Now that might feel weird, but if you just write out 4x equals 3x, that can be solved. What's the answer? X equals 0, yeah. And if you're like, I don't see that, well then so take away 3x from both sides, and you'd have x equals 0. There you go. And if you stick 0 in, it actually works. And then if you go back to the original question, if I put in a 0 here, will it really work? 4 to the 0 equals 8 to the 0. Yes, it works. Cool. Okay. All right. I'm going to go over and do this one. Find 3 points on the graph. Remember that the XY chart is your best friend in graphing. You just have to graph a bunch of points and connect the dots. The one thing you might get wrong with this is you might not have known where the asymptote was. I will remind you where the asymptote is for exponential growth and decay. I'm going to stick in 0 just because that's an easy number to put in. If I put in a 0 right here, that's 1/2 to the 0 is 1. 1 times 4 is 4. So 0 comma 4. 1 comma 2. And 2, when I put in a 2 here, that's going to be 1 squared is 1 over 4. 1/4 times 4 is 1. It's a weird little collection of points. But 0, 4, 1, 2, and 2, 1. If I actually go graph it for a second, 0, 4, 1, 2, and 2, 1, you might see it starting to turn. And this is how exponential decay is supposed to look. That is an exponential decay because you're multiplying by 1/2 over and over again. It gets smaller, smaller, smaller. Okay? And the asymptote for these kind of always run at 0. So if you were asked to graph this exponential growth, it would look like this, and the asymptote would still be here. If you were actually asked to graph decay, it would go down, 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 but again, it wouldn't touch 0. So if you were trying to graph something, the only thing I'm worried about is, can you find points? And do you know the asymptote would be? So let me ask you just about the asymptote. Don't even worry about the points. Would the asymptote that goes across at 0 get moved? On this problem, would I move the asymptote? Well, the asymptote that goes across at 0 only cares if you move it up or down. Like, think about it. This guy right here, if I move him, slide him left or right, he's still right on the same spot. It's just that did it go up or down? Did this one go up or down? Yeah, so you know where the asymptote would be? Can you tell me the equation for the asymptote, though? I know you're like, but it's a dotted line going across like this. Can you write the equation for it? Talk to the kid next to you. What would that equation be? It goes across like that, Andrew, right? It's just like the x-axis. So what is it? Y equals -1. Very good. All right. Cool. Now, one last one on graphing. Can you just find me 2 points on this one? That is not enough really for a test, but let's just make it faster. Find me 2 points that would be on this graph. Find 2 points. Well, what I'd do is make an XY chart like this, and I'd start with 0 and just see if it works nice. And it does, actually. 2 to the 0 is 1. 1 times 4 is 4. Minus 1 makes 3. 0 comma 3. Busselberg, can you give me another couple of points?
1 comma 7.
1, 7, and? Oh, you needed 2. That's right. All I said was 2. We're good. I think you get the idea. All right. So let's say that we're good at graphing them. Are you good at solving them? Well, first thing you got to know is that this square root symbol right here can be undone with a squared. And then I hope you remembered whether or not it has absolute values on this kind of a question. Does squaring both sides make you get 2 answers? And then this happens in every hour. There's usually some kids that are saying yes, there's absolute values, and some kids saying no, and some that just look confused. When you square both sides, you do not get absolute values. So it's just 2x plus 1 equals 4 squared is 16. And then you just solve it and you subtract 1 and divide by 2, no big deal. Make sure you get the difference between that and this. If I square root this, do you get that? Will bring in absolute values. Take a second and finish this question. The answer will have the square root of 11 in it, of course. I just did a square root on both sides. There's another little picky thing you learned in this unit. Brody, lock in. See that problem? Yeah. Do it. Okay. So, do you remember extraneous solutions? That came up in this cheap unit. That's where you get an answer and you don't even realize that, oh crap, that answer doesn't actually work. Because you go stick it back in the problem and you try it and then it doesn't work. Get used to that. Pre-calc loves that. You get like 2 answers. And then one of them is called extraneous. Because it's a solution that doesn't work. All right. So, Caleb, when I square rooted this, that caused what? What has to happen? What do I do to this side?
That's just 2x minus 1, right? And it's in,
Yes, that's the key. And it's in what?
parentheses column.
These are called absolute values. Absolute values, not parentheses. All right. So it's in absolute values. And now it breaks out into 2 things. 2x minus 1 equals, and 2x minus 1 equals. And they are identical except for a negative sign. Square root of 11, 1 to negative square root of 11. All right. Cannot stress enough how pre-calc isn't that hard. It is the algebra like this. It's going to get you. And that's why I made you do a whole extra sheet that, you know, that worksheet called the top 20. We are going to grade that. But in my first hour of class, I had so many problems. They had so many things I didn't remember from this unit that I did not have time to grade that. So we're going to grade it, but tomorrow. So keep that top 20 done. You may want to pick up one. I can hand you one. All right, so final answer on this after I add 1, 2x equals 1 plus square root of 11, and I divide by 2, divide by 2. There's my answer, 1 plus the square root of 11 over 2. Plus 1 plus 1. 2x equals 1 minus the square root of 11. And then I divide by 2. So 1 plus the square root of 11 divided by 2, and 1 minus the square root of 11 divided by 2. And yes, you could put them together if you wanted to. Okay. Heavy-duty math. This exponentials unit is something else. All right, and then the other one I gave you was this one. Last hour, when I gave one problem like this, I checked in the row, and there were 3 separate answers that kids had. So obviously, these are hard. If you get honors kids getting 3 separate answers. This particular one isn't that bad, but the one I'm going to give you in a minute is a beast. This one, what you should have done is this kind of power, you just multiply them. So that's x to the negative 4. I'm just going to do one thing at a time. Times 2x to the negative 3. Now you got to know what to do with that 2 and what to do with this x to the negative 4 and the x to the negative 3. Those can be combined and they make x to the negative 7. If you said 2x to the negative 7, you were so close. Why is that wrong? Tease, you know why that's wrong? Yeah, what's wrong with it? What part's not simplified? Yeah, you can't let answers have a negative exponent. So, final answer, 2 over x to the 7th is your final answer. Who had that one right? Be honest. All right, and that's about half of you. So we should practice that kind. All right, I'm going to do another one like that. You ready? Write this down, please. 3 times x squared y to the 3rd all over, in the parenthesis, 2x to the 3rd y, all of that to the negative 2. That is something that you're supposed to be able to simplify down. I would do one little step at a time. Don't try to do it all. Even I would have trouble doing that. All right, the first mistake kids can make is they think they can distribute this 3 in there. That's not a thing, because there's no plus and minus in there, so you can't do that. So it's just a 3 on the top. So is there really anything you can do on the top? No, there really isn't. It's just 3x squared y to the 3rd at first. And then on the bottom, we can do something. Now, there's 2 different ways to do this. I can go through and take this 2 and put it to the negative 2, and then take the x and put it to the negative 2, and then take the y and put it to the negative 2. Or I can take the whole thing, since it's a negative power here, and move it all up to the top. And if I put it up on the top, it'll be the exact same thing it was. 2x to the 3rd y. But now it's to the positive 2. And look, everything's on top. Now I can just simplify it down and put it all together. That 3 can go with that 2 squared, which is really 4. 3 times 4 is 12. Now I'm going to go do the x's. I have x squared here. X to the 3rd to the 2nd is really x to the 6th. Put it with the x squared. I got x to the 8th. And y to the 3, 4, 5. 12x to the 8th, y to the 5th. Raise your hand if you had the same thing as me. All right. That kind is hard. Okay. So now we've come to the word problem part of the chapter. So if I said that I was raising mongoose, not sure, is it mongoose if I have like 10 of them? Mongooses, probably. Anyway, so let's say I have 10 mongai, whatever they are. I put it in front like this, and then I go, I'm going to try to raise these things and like sell them. So I want to get them to grow, but let's say I'm a terrible mongoose farmer, and it goes like this. Do you see how that's going to make it decay by 25%? And then if I only keep track every 18 months, and that's how I know it's 25% lower, every 18 months I'm like losing my mongoose population, then I go x over 18. And that would mean every 18 months I lose 25% of my population that started with a 10. Could you have made that equation? Because I'm going to give you another story now, and you have to set up what is called a mathematical model for the exponential. All right? So, story time. So you want to take some money that you made working at a restaurant. My daughter worked super hard at this restaurant called Birches on the Lake. It's in Long Lake, which is near where we live. And it's a really nice restaurant. And if you ever thought, well, I'm too young to be a server. Yeah, but you could be a wait assistant. And the wait assistants get tipped too, because they work for the servers And the servers make the big bucks on the tips, but they can share, and they do share their tips with their wait assistants. They're typically told to give them about 10% of their tips. And they run around and do all the nasty, like really hard stuff, like carrying stuff off the table and wiping the tables down and all that kind of stuff. So she made like $5,000. That's the beginning of our story. She made $5,000. And she was smart about it. She invested it. She stuck it in the stock market. And let's say she never touched it. But it was getting 10% growth every year. But just to make the problem a little harder, instead of 10% growth every year, it's 10% growth, but it takes only 9 months to get 10% growth. How do you factor that last thing? Check with the kid next to you, see if you get the same thing. Every 9 months you get 10% growth.
It's just X over
We should have known to start with 5,000, of course. And then you should have known that it's growing by 10%. If you just put 1.1, that's the same thing. And then it's just, if it had just kept it simple and said 10%, it'd be like that. But I said every 9 months, so divided by 9. Raise your hand if you had that one right. Okay, awesome. You got that kind. All right. There are so many different kinds, though. Next thing is, do you know how to handle negative fraction exponents? Like, for example, 27 to the negative 2/3 power. Do you remember what that means, Eve? You should be able to get this down to an answer like 4. And if you're struggling with remembering it, I get it. But then take notes on this. Write down what each thing means. I'll tell you what they mean. In this power, the only thing normal about it is the 2. That is just a power of 2. It's like 27 is being squared. But it also has 2 other things happening. Do you guys remember me saying that the root goes on the bottom, just like in plants? Okay, so that is the 3rd root of 27. And we're going to square it. And the last thing we're going to do is that negative, which you could think of 2 different ways. I like to think of it as flipping it. Another way you could think of it is it puts 1 over it. So given that, you should be able to take the cube root of 27 in your head, then square it, and then flip it. Talk to the kid next to you about what you think that answer is. Okay. Cube root of 27 is 3. 3 squared is 9. That makes it flip over to be 1/9. Raise your hand if you had 1/9. Okay, awesome. Okay. But what if it was x to the negative 2/3 equals 3? And how do you solve that? First question for you is this an exponential? Do you even know what that means? Is this an exponential? No, because exponentials have to have an x in the exponent. This does not have an x in the exponent. Now, you could say it is written with an exponent. That's true, but this is not an exponential. All right. But you can solve it by getting x alone. So you put it to a power. How many of you were thinking put it to the power of negative 3/2? Be honest, that's what you thought. Raise your hand if that's what you thought. Because you were right. Good job. That's what you do. Because then this and this are called reciprocals. They multiplied in 1. And then x is just to the 1. Yay! But did anybody remember that we just square rooted both sides? Nice. 1 person. 2 people. Good job. We square rooted both sides. Because see this? That's a square root. That means that it's the absolute value of x, which means we're going to get 2 answers. And I have no clue what this is. Square root of 3? What the heck? And then I'm going to put it to the 3rd. So I'd be totally fine. You're going to have a calculator. With using a calculator to type that puppy in. Let me see if Siri's smart enough to handle that. I doubt it. Let's see. What is 3 to the power of negative 1.5? Do you want me to use ChatGPT to answer that? It says 0.192. You guys agree? 0.192? All right. 0.192. All right. Do you get that it would have been super easy to forget the absolute values and then therefore super easy to forget that there's two answers? That would be super easy to forget. Okay. And the last thought is, this is the chapter that has extraneous. Do you get that at the end of a problem, especially that had square roots in it, you might want to make sure that the answer actually works. Take this one for instance. Solve it, get an answer, and be skeptical. Like, Like, this is the guy trying to carry the giant duffel bag onto the plane. You're going to be like, I want to look in that duffel bag, sir. We're going to check this one. Because this one might have an answer. It's called extraneous. Okay, did you start by squaring both sides? That'd be smart. Does that bring in absolute values? No, it does not. Subtracting x from both sides. Negative 3x equals negative 1. X equals 1/3. The problem is, if I go back in and put 1/3 right here, do you get, first of all, did you get 1/3? Okay, did you realize that it doesn't actually work? Now, obviously, I said this in the context of, you better check the answer. Like, you're going to forget, though, on the final, that you better check the answer. Yes?
How many questions are on the final?
It's a good question. I don't have that answer yet, but typically it's like around 50-ish questions. It will take you the full 2 hours. Like, this will be an intense test. All right. So again, I got x is 1/3, and then I realized when I put it in, on both sides, I get square roots of negatives, and that's not legal, so therefore, that's called an extraneous answer. And therefore, you'd go EXT. On a test, if it was a multiple choice question, one of the options would have been x equals negative 1/3, which is extraneous. So they probably would have led with answer A, would have just been x equals 1/3, and a lot of people will be like, that one. And they forget to check, oh, wait a minute, there was an extraneous option. Okay. Well, there's a lot to this chapter. I'm only assigning the odd ones. So if you've started it ahead of time, yay for you, but all we're doing is the odds. And I strongly recommend you check your answers. And there is one question that it was super tricky on how you get it. And I want to tell you, we wouldn't have anything that tricky. And therefore, let me tell you which one to skip. So we're doing the odds, except you should skip number 27. Cross off number 27, because the only way I think you could have got that is by graphing it. You'd have to graph it and see where the two equations cross. And then super advanced. Something that we would not do to you on the final. Okay. So, this is the part where I want you to pull up that homework. I want to walk around and make sure that you are actually starting said homework. And make sure you cross off all the even ones and number 27. Then you have kids next to you that are working on the same exact thing as you. So I encourage you to ask them, like, hey, what'd you get for number 4? that you have other things in your life. But for the next few minutes, I ask that you just work on math. That way, if you get stuck, you can get some help from me. All right, that's all I got for the video for today.